Now let's move on to question number 7. The diagram shows the curve y equal to this, okay, great, which crosses the x-axis at the point O, the point A, and the point B, as shown in this diagram. Right. Now part 1, the tangents to the curve at A and B, they meet at the point C, find C. So we have a tangent at the point A and B. So tangent here will be simply a line. For example, it could be a line in this direction. Tangent at B should be something in this direction. They meet here, and this is your point C. So again, this is a point of intersection, so we have to find the point C by solving a simultaneous equation. But first, we must find the equation of tangent of B and tangent of A, and then joining them at C by solving them simultaneously. Again, one by one, you have to find the tangents. So to find the equation of straight line, we must first find gradient of the lines. So begin one by one. So here we know y is this, so let's expand. Y is equal to what? That will be x squared minus x multiplied by x minus 2. Expand, you will have x cubed minus 2x squared minus x squared plus 2x. That will be, so let's see, what do we have finally? So here we have x cubed minus 3x squared plus 2x. This is my value of y. Now I do understand that to find the gradient of the curve at any point, we have to find dy by dx. Or gradient of tangent is dy by dx, as we know already. I mean, you guys should make a note of this. The gradient of tangent on a curve is dy by dx. That should be 3x squared minus 6x plus 2. This is dy by dx, right? Now, we have to find the equation of TA first. We have to find the gradient of the line TA first. That will be dy by dx at the point A, where the value of x is equal to 1. Simplify, you have 3 times 1 minus 6 times 1 plus 2. That should be 3 minus 6 plus 2. That should be what? 3 minus 6 plus 2, that should be the value of minus 1. So the gradient at the point A is minus 1, and we have a passing point A is equal to 1, 1. So passing point A is 1, so 1, 0. This is my x value, my y value. So I have to use the passing point and the gradient to find the equation of the line. That'll be y minus 0 is y over x minus 1 equal to the gradient. We can cross multiply, you will have what? You will have y is equal to 1 minus x. So my line here for t of A, tangent of A, at the point A is y equal to 1 minus x. So now same thing, we have to go find the equation of tangent of B. So the gradient of tangent B is what? It is 3. At the point of B is x equal to 2. 3 times 4 minus 12 plus 2. So 12 minus 12 plus 2, that should be 2. Now we have a passing point, which is the point 2, 0. So here we have minus 1, this is 2, so that is the x value, y value. Y minus 0 is y over x minus 2 is equal to the value of 2. Cross multiply, you will have what? You should have y is equal to 2x minus 4. That will be my equation of my line or my tangent at B. Now again, to find the point C, that's the main goal here. We understand that these two lines intersect at the point C. Now to find the point of intersection, we have to solve the equations simultaneously. Let me write these two down. The first one is y equal to 1 minus x. Here we have y equal to 2x minus 4. Equation number 1, equation number 2, they meet, so we have to solve simultaneously. Here we have y as subject already. Replace in this y, you will have 1 minus x equal to 2x minus 4. Send this over here, you will have 5 equal to 3x. X will be 5 over 3. Y should be 1 minus 5 over 3, and that will be what? Let's see. That should be 3 minus 5 over 3. That should be minus 2 over 3. The point C will be 5 over 3 and minus 2 over 3. Okay, so that should be the value that we have for this point. Now let's move on to the next question. So part 2, we have to show by integration the area of R1 is the same as the area of R2. So pretty easy. Let's find one by one. I actually want to check if this is okay. Let me replace here. 2 times 5 over 3 minus 4 should be minus 2 over 3. Okay, good, perfect. Now this one is we have to find these two areas separately, and then we can compare if they're the same or not. So to find R1, it is area between the point here is 0. The point A here is 1, 0. This is 1. Limits is 0 to 1. Let's find R1 first. So to find R1, again, it is area under curve should be limits of 1, 0, as we can see right here. And the equation of the curve was found to be this, x squared plus 2x respect to dx. Now we just have to simplify. That will give you x power 4 over 4 minus x power 3 minus this will be this was cancelled out, 3 divided by 3. This will also cancel out. You will have x squared, and this will be limits between the values of 1 and 0. So simplify. 1 will be 1 over 4 minus 1 minus 1, and then minus the value of 1. So let's see, what do we get? So this one's supposed to be kind of strange, but let me double check. So here we have x power 4 divided by 4 minus 3x squared plus 1 divided by 3 minus, fair enough. And then here we have 2, this will go away, fair enough. Now this obviously will be minus 0 for the rest. So here we have 1 over 4 minus 1 minus 1. That should be minus, this is plus 1. See mistake here, plus 1. So this will cancel out, so you will have 1 over 4 as your answer for area of R1. So you can see, please avoid silly mistakes. You have to always double check your value at the end. This is the area of R1. Now for R2, let's find out. Same steps. Limits is from 1 till b. Here is what? It is 2, 0. That will be 2. Limits is 1, 2. So 2 up, 1 here. Same steps. X cubed minus 3x squared plus 2x respect to dx. That will be x power 4 over 4 minus x cubed plus x squared. That will be 2, 1. Simplify. That should be 2 power 4 divided by 4. That should be 4 minus 2 power 3 should be 8, and then plus the value of 4. That's the first part. Minus, here we have 1 over 4 minus 1 plus 1. That should be 0. Minus here, that is 1 over 4, and that will be 0. Again, the value here is minus 1 over 4, but for the area, obviously, it is just 1 over 4. The reason why it is minus is because the area is below the x-axis. That's why it is minus, negative. However, the area, we don't have a sign value for area. Area is area, right? We don't take sign for area. Area is this whole thing. That should be 1 over 4, and this is also 1 over 4. So as shown as required, R1 is equal to the value of R2 by integration. And that will be this question in regards to some integration and some differentiation.